Hello there, everybody. Welcome to the technical first episode of the new Python coding tutorial series. Last episode, we talked a little bit about the setup process to get Python installed on your computer, get PyCharm set up, and then we just went over some basic housekeeping where we learned all about printing, which is very easy to print things. We just type in what we want to print, put it in quotes, and pass it into that print function. We're going to talk more about functions in probably the next episode, but today I want to talk about variables. Variables are quite exciting. Here's one little tip for you that I did right here. When you put in 3 triple quotes, these are for commenting things out. So you actually, this code will not run whatsoever. I could put in a print statement in here and say, print variables. But this is actually not going to run, and I can show you this. We can run it. You'll see that nothing printed out here because there's really nothing to print. It's all in a little comment. So we're going to talk about variables today. And what is a variable? Well, if you have taken an algebra course, then you would know that a variable is basically just a symbol that means something else. In algebra, it's normally x, where, x plus 1 equals 2. You subtract the 1 from both sides, you find that x equals 1 kind of thing. Works a little bit similar in coding, and especially in Python, where variables hold values for us, and we can define them in a variety of ways and in a variety of types. Now, those of you that are coming from another language, such as Java, C++, C, those are probably the main ones that you would do if you've had coding experience and are just trying to learn Python now. You would know that you have to define your variables by putting the type in front of them and then defining them, something along the lines like this, where int stands for integer, and then you got the name of your variable equal to 10. No, not in Python. In Python, we can just tell the computer, hey, x is equal to 10. And Python is going to go in and it's going to completely understand what is going on with this. So let's talk a little bit about the different types of variables that you can have in Python. We're not going to actually go over all of them. We're going to cover a couple of them today, and then there will actually be separate episodes for a few other ones. But we're going to do some variables, what they do, how you make them, and then we're going to kind of go into some math functions that we can do with numerical variables, and then we're also going to talk about strings and some various things that we can do with strings. So this is one way that you can define a variable, x equals 10. It doesn't have to be x. It doesn't even have to be a single character. We can call this anything. We can call this Tyler's favorite random number equals, and my favorite number is 64. So we can have a variable called Tyler's favorite random number. It's telling me that this is not a word. No kidding, it's not a word, but we could call it this, Probably don't want to. You probably want to call it something that actually is relevant to what you're coding. When you name variables, you want your code to be readable to you and to anyone that would be reading your code. If you start calling them, XYZ is your variable, nobody knows what XYZ is. So you're going to want to call your variables something a little bit more robust and relevant to your code that you're writing. But for our sake here, we're not really writing a script that does anything, so I can just call it x, and I'm okay with this. So this right here, x is going to be a integer. And how do we know that? Well, if you've taken a math class before, you would know that an integer is any set of real numbers that are whole numbers, meaning that they don't have a decimal on them. 10.1 or 10.2, 10.3, something like that. This is just a flat 10. It could also be a flat 5. It could be 0. Integers can even be negative numbers. We can call this negative 50, and that's okay. We cannot put like pi in here. A little bit different. We can actually do stuff with pi in Python, but we'll cover that another time. So let's make x equal to 10. How does Python know that this is an integer? Well, it's looking at a variety of things. It's seeing a 10 here, and it's saying, he probably thinks that it's an integer. How can we check that it's an integer? Well, we actually have a really interesting function called type. And type is a good function for learning what the type of a variable is. So we can actually do type of x. And x obviously is our variable that is holding the value of 10, so we can see what the type of x is. Now, if I run this, you're going to find it didn't do anything. It didn't tell us anything. And why didn't it tell us anything? Because we didn't tell it to show it to us. We have to print if we want to see what that value is. So this is actually a nested function right here where we are printing the result of a function. So let's print the type of x, and we will see here that this is of class int, which stands for integer. We can do this with a bunch of different variables. So we can also define y here, and we can define y as hello world, which is a string that we created last time. Strings are always stored in double quotes, a double quote at the end, a double quote at the beginning. And we can print the type of this as well. Let's add another print statement and let's do the type of y here. And the type of y, as you can see, is class 3, which stands for string. It's a string. Don't worry, it's not a street. It's a string. We have an integer. We got a string. What other variable types do we have? Let me come in here. We can add a pound sign or hashtag for all you dang kids out there. And we can kind of comment this out and say, this is an integer. This is a string. Let's come down. Yeah, you know what? I'll continue this here. So z, what's going to z be? Z is going to be 10.5. And I know you said, Tyler, we can't have decimals. Well, we can have decimals. It's just they're not going to be integers. They're instead going to be floats, which stands for floating point value. It's any value that has a decimal in it. And we can print this up, and you will see that this is of class float. There's one more data type that I want to explain in this video, and I will call it Morpheus. Why not? Morpheus can be true, or Morpheus can be false. And this is what we refer to as a Boolean. Those of you that have taken a Boolean logic class before, you will know what I'm talking about here. But a Boolean basically just says, give me a true or false value. And in Python's case, true is actually equal to 1, while false is equal to 0. And we can do a test on that in a second if you do not believe me. So let's print the type of Morpheus, and we will see that this is of class bool here. So let's do a test on that. If you don't believe me that true is the same as 1, let's do a little if statement. And we're going to cover if statements in an entire video, so don't worry if you do not understand what I'm about to write, but you should be able to follow along pretty easily. So if Morpheus is equal to 1, then print they are equal. Okay? Let's run this, and let's see if we get it to print they are equal. This is only going to run if Morpheus is equal to 1. And we could even go so far as to say if true is equal to 1, which is very strange. I'm going to stick with if Morpheus is equal to 1 because that's the variable that we have defined here. So we can run this, and we will see they are equal because Morpheus, true, is the same as 1. Now, if we were to say is Morpheus equal to 0, this is not going to tell us that they are equal because true is not equal to 0. False is equal to 0. And we can prove that as well by just typing in false here. And you will find that when we run this, they are equal because false is equal to 0. So why even have Booleans as a data type? It's simply easier at times to write in true or false than it is to store things as a 1 or a 0 as an integer. It just is a nice thing to have, I guess, is what I'll say there. So there are a couple of other data types out there, and I will kind of list them here. Haha, a list. A list is a data type, a tuple is a data type, and then a dictionary is a data type. And these are kind of the three main other ones you'll see, but there's also ways for us to define variables as our own type. And I know you're going, Tyler, that makes very little to no sense in my mind right now. But allow me to give a quick demonstration of why you might want to do that. So let's say that you have a video game, okay? And you want to have a character in that video game. You may define a data type as that character. He's going to have a variety of other characteristics about him. So we're basically, in a very simplistic way, I'm going to kind of do this over here so you can see. What if our variable, our data type was character, but then that character had various other data types inside of it, such as maybe the health of the character, and we could store that as an integer. Maybe the character has a name, and we could store that as a string. Maybe that character has weapons, possibly, and those weapons may be stored in a list or something like that. So we're going to cover that in a future video. I don't want you to worry too much about that at the current moment, because those are classes, and classes are a little bit of a more complex subject. But just know we're not tied down to these basic 7 here. There are some ways that we can just completely make our own. So it's pretty cool. Let's do some math, which I know nobody likes math, but we're going to do math because a lot of coding is just math in the end. So let's do some math. This is going to be basic math. Don't you worry. Let's define a variable. We're going to define it as x equals 10. And then we're also going to have a variable y here that we're going to do as 20. Okay? Now we can add x and y together, and we can print that out. So we can say print x plus y. And this is, pretty easy math to figure out here. 10 plus 20 should be 30, and when we print this, we will see it is indeed 30. Now that value, we can also just straight up store that in a variable. So we can store x plus y as z. And this is still pretty easy to follow. Z is going to be a new variable that we're defining, but we're going to make it equal to x plus y. And now if we print z, we should see that z is also equal to 30, and it prints that. And we can prove this. We could say if z is equal to x plus y, and we can put this into quotes here, then print they are equal, as we have been doing. And this is a good way to just test to see if everything is going how we intend it to do, and it is absolutely equal because we know it. I mean, z was equal to x plus y. In our conditional, we're basically checking if z is equal to x plus y. That's actually a good thing to cover right now, and we'll end up covering this in conditionals again. There's a big difference between equals and double equals. Equals is used for assignment. This is how you assign a variable to a value. We're assigning x to 10. We're assigning y to 20. As for this is checking for equality. It's checking is something equal to something. In this case, is z equal to x plus y. Think of it as x equals z is equal to. Those are kind of the two main phrases you want to use there. So, common mistake to do something like this. This is going to give you a big old error. This is actually not even going to run. It's going to tell you it's invalid syntax because you can't assign something inside of a if statement here. So it's got to be a double equals. But like I said, we're going to cover that more when we get to conditionals, which will be in a couple of weeks probably because we have some other stuff to cover. So there are some other mathematical operations we can do here. Let's actually change x to be 100 here. And then let's make, instead of a plus, let's do minus. So z is equal to x minus y. This is going to do exactly as we intend. 100 minus 20 should be 80. We can run that and we will see that it prints out 80 as our value. All things are good. What happens if I do something like this? 10 minus 20. Is it going to give us a negative number? What is that negative number going to be like? Find out next week. Dragon Ball Z is going to give us negative 10. I'm not going to beat around the bush here. It does exactly what you would expect. You're subtracting two integers. Negative numbers are integers. It's going to do just as we intend it to do. This is where things can get a little bit more interesting. So I'm actually going to make x equal to 1 now and y equal to 2. Let's do some multiplication, which is done with a little star. So x times y, that's 1 times 2, should be 2 when we run it, and it is absolutely 2. But then let's get really weird. Let's do x divided by y. So 1 divided by 2. What is going to happen when we do this? Well, it's going to give us 0.5. So this is where Python is pretty intelligent in the way that it does things. We have x, which is definitely an integer, y, which is definitely an integer, Z is not going to be an integer. And that's something that is unique to Python in the fact that variables can kind of morph. They can take on different variable types that might not be expected. A lot of other programming languages aren't going to work like this. So Z, we can print out the type of Z as well here. We know how to do that. It's just a little bit of type action in there. We can run this and we will see that this is indeed a float, even though it came from two integers. Now, just to confuse you even more, that was basic division in Python. There's actually two other kind of types of division out there. So you have integer division. What is integer division? It means that you're going to divide integer by integer and get an integer. So how is it going to do this? Well, let's see. We know that it's supposed to give 0.5, but it is not going to give 0.5. It's going to give 0 as the value, and that's because it's going to round down whatever that value is. So we can actually do something along the lines of 5 divided by 2, which is going to be 2.5 if we do it like this, and we can test that right here, 2.5. But now if we do integer division, it's going to do that round down, and you're going to see that this is actually just equal to 2 when we add in the extra slash. You may be going, when am I going to want this? You'll find times where integer division is more useful than regular division. It just happens. And those times I can't really give you a surefire reason as to why you're going to want to do that, but you might, and that's sometimes good enough, honestly. So here's another one that we're going to talk about, and this is the final operator that I'm going to kind of talk about today, and that is modulo, which is something that sounds like a spell from Harry Potter, but I promise you it is not. This is a mathematical function that is commonly used in programming and in Boolean logic and things of that sort, used in cryptography a lot, which we might do a tiny episode on crypto sometime here. But modulo is a really big word for just the remainder, which is something that if you've done long division before, where you have 50 goes into 1500 how many times kind of thing, and then you box it off in this little thing like this, we've all seen that before. And then you go, okay, 50 goes into 150 3 times, and then that goes down and you write 150. What happens when 50 does not go evenly into 1500? Let's say that instead this is 1503. So then we come over here and typing out long division is not something I planned on doing today, but we would bring the 150 over and then we would subtract, and we would find that this is 3, but then you have that remainder of 3 at the end of it. This number 3 is what the modulo of 1500 mod 50 is. So let's test this. Let's do 1503 mod 50. Okay? And let's print this out, and we're going to see that this is in fact 30 because I lied directly to your face. I lied directly to your face because we did not change the operator. We have to do modulo, which is a percent sign, and then we can test and see that this is in fact 3, as we intended for it to be, because the division is indeed, if we do a basic division here, we will see, well, actually, we genuinely want integer division, because this comes out to be 30, as we know. But then it's 30, remainder of 3. And since the integer division will just chop off the remainder decimal part, we could do a regular division here, and we will see that it is 30 point something. So it just rounds down to 30 when we do the integer division. But that remainder part is 3, and that is what the modulo is. Let's do this with a little smaller example, just to prove a point here. So what is 4 mod 2? So let's do the long division here. So this would be 2 being divided into 4. We can make our little division symbol that we normally do. Well, 2 goes evenly into 4. I mean, it's just 2. So there is no remainder on this one. And that makes our life pretty freaking easy, because this is literally going to be 0, as it doesn't like my comment down here of all of the various things. This makes my life pretty easy, because the modulo of 4 mod 2 is just 0, because it divides evenly. If it doesn't divide evenly, your modulo is going to be 0. which makes life simple. Let's do a little bit more complicated one. Let's do 13 mod 2. And you might already be able to do this one in your head, but let's do our standard thing here. So 2 goes into 13 how many times? It goes in 6 times. And then, obviously this comes down. You would have a 12 minus 1. We'll have a remainder of 1. So 13 mod 2 should be 1. And the survey says, indeed it is. It is 1. Very exciting. Good stuff. That's Modulo. You will use this in various scenarios. So get used to it. It's a good one to practice. Let's talk about strings a little bit. This is how we're going to end off today. And strings are kind of the lifeblood of coding. You're going to use strings everywhere. Every little variable that you make, I guarantee, is going to interact with a string in some way, shape, or form. So let's do that. Let's do that a little bit. So important thing to know about Python strings is that they are, in fact, immutable. And what does immutable mean? Let's make a string hello world here. So immutable strings mean that you actually cannot change a value inside of this. You can pull pieces out of it. We can pull out the W from hello world, and we can call that. It's pretty simple to do this actually. Let's do a x dot replace of x with, we're going to replace W with a, I don't know, V, okay? We can do this, and this is a simple function for strings is replace. We can replace that W with a V, and it's going to now say hello world, which is apparently the Russian way to do a coding tutorial, but this is actually going to make a brand new string. It's going to take a copy of X and it's going to make a brand new location in memory for that X. This might not make any sense to you whatsoever, and that's okay because you're likely just watching this as a beginner. Just know that Python strings are immutable, and we're going to find another data type lists are immutable, meaning that we can change values inside of them, and that same data structure will remain the same with that new addition or new subtraction or just changed value inside of it. So strings are immutable. Going off of that, let's talk about how we can index this string and pull some values out of it. So x is equal to hello world currently. What if I wanted to grab the H in hello? Well, we could do something called indexing. And indexing is pretty useful for strings because we can pull these values out. So it's just 2 brackets, open, close bracket, and then we'll have some values inside of them. So how this works is we want to index our variable x. So we put x out front and then we index it. And how are we going to index it? Well, we're going to pull the first position of that string and we're going to print this out. So in Python and in most coding languages, I'm not going to say all because there are some that are heathens and start things with 1, but everything's going to start at 0. 0 is the first position in the string. So if we were to actually map this out, and we can do that up here, and this will make our lives easier as well. This will be the 0 position. This will be the 1 position, 2 position, 3, 4, 5, 6, 7, 8, 9. This will be the 10 position, 11 position, and then 12 position does not exist because it is indeed ending on the exclamation point. And we can do this. Well, that actually messes it up because now there's extra spaces in there. Sometimes life is hard, dude. Anyway, we know that x at 0 should be equal to the capital H. And we can run this and we can see that is indeed the capital H. We could grab the 10th position, which we know should be the D in hello world. And it should just be a D. Fantastic. Just like that. We can grab the 11th position, which should be the exclamation point. You kind of understand how indexing works here. Now, what happens if I say, give me the 12th position? What is going to happen there? Well, Python's going to tell you, no, I don't think you should do that. It's going to tell you that your string index is out of range because it is. We don't have a 12th position on this string, so we are indeed out of range. Now, what if I tell you x at -1? Is this also out of range? Well, Maybe not, because now we got an exclamation point. So the really neat thing about Python strings is that you can go into the negatives to pull whatever the last value is. So we can say, what is x at -2? And if x at -1 was an exclamation point, one can assume x at -2 is in fact a D. Super weird, right? So let's see. This is actually, as well, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12 should be a capital H as well. And indeed, it is. So now we can pull out a weird if statement here that says if x at -12 is equal to x at 0, then let's print once again, they are equal. And I see no reason why h should not be equal to h, even though these are two very separate indexes. It's pretty cool here. Now we can do some more advanced indexes as well. Let's say we just want to pull the word hello out of this string. We can do something along the lines of x from 0 to another value. And we can use this little colon as a going to something. So in the grand scheme of things, and I'll put this over in our comment here, you're going to have inside of your index, you can have up to 2 colons in here before you get to your final bracket. This is going to be where you start in your index. This is going to be where you end in your index. And then you can have an optional last one, which I know we have not put in, but this is a step. And I will demonstrate that in a second. But say we wanted to grab only every other letter. You know, we can grab H, L, O, W, R, D. Then we can do a step of 1 to skip over every one character. But to start, let's grab hello here. So where you start is always inclusive, meaning that we will include whatever number we add in there. So that is inclusive. Where you end is actually exclusive, which is a little bit annoying, but doesn't take too long to get used to. So what I'm saying here is, if the 0 is inclusive, or if where you start is inclusive, then putting a 0 here will indeed start us at the H, and it will print the H. And then if this is exclusive, then we want one more than where we have. So let's go 0, 1, 2, 3, 4. So if we want to grab only these 4, then we actually want to make this go to 5, because it's not going to include that 5th position, which is a space. And we can print this out, and we will see that indeed x from 0 to 5 is hello. Very useful. Now, what other weird things can we do here? Well, we can say, let's go from 0 to 5, but let's have a step of 1 in there. And let's see what happens on this one. Well, we have hello, because it's not skipping anything, because this should be a 2. I said that wrong before. But now we have HLO, because it's going to do a step of 2 over to each next value. And we can do, all the way up to 11, skipping 2 each time. And we will see that this gives hello-rid, which is this H, this L, this O, W, R, and D. So let's do one more unique thing with indexing, and this is pretty valuable. We're going to use indexing a lot in our scripts. Let's do something super weird, okay? Let's do an index of ::-1, okay? So basically what this is saying is go from the beginning to the end, but go backwards. So theoretically, this is going to print out hello world, but it is in reverse. And this is a really way for you to reverse a string if you want to reverse a string. If you don't understand this, don't worry. That's a pretty niche indexing function to do here. But it's still useful to know that you can do that little -1 in there to make your life interesting. So now that we know indexing, let's talk a little bit about concatenation. So let's say that we had x is equal to hello, and then y down here is equal to world. Okay, well, we can do z is equal to x plus y, and because these are strings, it's not going to try to add them together as numbers. It's going to instead add them together as strings, and it's just going to concatenate world to hello, because that is what we were doing. You're going to find one big issue, though. We lost our space. Well, what the heck happened? No worries. We can add that space in, and we can say, while you're at it, just add a space in there. Pretty easy to do that. Just add in a space. And we can run that. We can see that we're right back to hello world. Z is our, hello world original X value that we had, but we kind of split things up and did some concatenation around the way. We can keep on going with this. We can say, hello world, my name is Tyler, kind of thing. We can save this, run this, and we'll see, hello world, my name is Tyler. You might want to have a space right there if you want it to look as pretty as possible. But now Z is, this big, long, hello world, my name is Tyler string. Now, dude, if we want to reverse that string, I know you all want me to. I can see it in the comments already. There you go. There's hello world, my name is Tyler reversed. As easy as ::-1, putting the Michael Jackson song to shame. So what are some other things that we can do with strings? So you did see one. We can do the string replace, and it's pretty easy to do that. And we could set that equal to a new value. So replaced string is equal to z.replace. And let's replace Tyler with Bob. How about that? So what this is going to do, it's going to go through our string, which obviously is hello world, my name is Tyler, and it's going to look for this value inside of it. It's going to look for Tyler. And if it finds Tyler, it's going to replace it with Bob. And we can see here that we now have, I didn't print it. It's always a good thing to print your string once you set it, if that's what you want to do. Hello world, my name is Bob, even though clearly our string is hello world, my name is Tyler. Pretty good. What are some other things that we can do? Well, sometimes when you're handling a lot of data, let's say that you have an Excel document up on your computer, and you have a bunch of data inside your Excel document that you want to get into a Python script. Well, maybe that data is a little bit ugly. Let's say, you have a bunch of spaces at the end of hello. You got a bunch of spaces at the beginning and the end of world. What we can do is we can strip off all of that white space. We can say, just strip off that white space by doing .strip. And this is now going to give us a string that, if we print out Z, we will see that this is going to look terrible because we have all this white space inside of our variables here. But maybe we want to instead print out a replace string. And you're going to see, and maybe you've already caught it, that this is not going to do what we expected it to do, because the white space is not at the beginning or the end of our variables. So it didn't change anything because it's trying to strip off of the end. What we really need to do is come in here and say .strip on these strings that aren't even variables yet. This is totally allowed to do this. And we can now print Z, which is going to be nice and simply back to normal. Forget about this for right now. I feel like that complicated things a little bit. We can call these functions on strings as you're assigning them, which is a little bit funky, but you can still do it. If you don't like that, then you can absolutely do x is equal to x.strip, and that is totally fine. You can assign values to themselves. There's no issues there. Yeah, that's about all I got for strings. There's a couple of more interesting things we can do with strings once we get into lists and things like that, loops, things like that. But we're not going to cover that today. I feel like this is a pretty good amount to start with. I do want to real quick on the topic of assigning a variable to itself, just want to show you a little bit of a shortcut. So let's say that x is equal to 10, and we want to add 5 to that value. Well, yes, we can say x is equal to x plus 5. That is fine, and this will obviously resolve to be 15 because 10 plus 5 is 15. But we can also do this a little bit more efficient. We can save ourselves a couple characters. So we can say plus equals 5. And this is equivalent to x is equal to x plus 5. And we can do that, and you will see that it is still 15. You can do this with all of the operators. So minus equals 5. You will see that that is indeed 5. 10 is equal to 10 minus 5, which is 5. We can do that with multiplication as well. You won't see this one often. I'm going to tell you that right now. That's a big old 50. And then I believe you can do it with division, but I'm going to be real. I've never typed that a day in my life. And you absolutely can. It becomes a float of 2.0. So pretty good stuff. That's a lot of information to take in. This will be one of the longer of the videos just because we were covering a ton. Printing, variables. We covered, defining variables in another language versus defining them in Python. We covered variable types, which, if we remember, those are integers. They are floats. They are strings. And they are booleans. We also know that there's other data types that we're going to talk about in the future. We learned how to add, subtract, divide, multiply. We did integer division. We even did modulo, which, if you remember, is the remainder of things. We talked about strings. We learned that strings are immutable, and you'll actually create a new string if you make any changes to it with replacements or things like that. Another way to test that strings are not mutable is to say, okay, x is now equal to the string hello. We cannot say that x at 1 or at 0 is equal to a j, meaning that let's change that x value, that h value, to be an j instead, and make x equals jello. This will not work. It will yell at us, and we can say that string object does not support item assignment, meaning that we cannot change anything inside of this string. Strings are indeed immutable. We talked about indexing. As you can see right here, good old x at 0 is going to equal h. We learned about concatenating. We learned about reversing strings, and then we learned about some new math operators. So that's going to do it for the first episode, real official first episode. I do want to reiterate again, leave any questions you have. Feel free to put little blurbs of code in the comments if you have any questions on specific things. We'll have another video here this coming week that will just answer some basic questions that you guys had. That'll be a little bit faster. I'll do some examples of things. And then next week, we'll cover a new topic that will likely be loops, probably. We'll see. I'll let you know. Thanks so much for watching. Subscribe if you are not subscribed to the channel and have found me in a strange way. I promise I do not always do gaming stuff. I that's not true. I primarily do gaming stuff, but I do these tutorials, and hopefully they're a little bit useful for you. You have a good one. I'll see you guys next time. Goodbye.